Welcome back, mathematicians. In this video, we are verifying with algebra that two functions are inverses. You can also verify two functions by graphing them as well, and I do recommend that you get used to using that. If that's part of your homework, go to a graphing program like Desmos. Simply insert the two functions in and verify that they are mirror images across the line y equals x. I've put two examples in here below so that you can see what they would look like. This dotted line is y equals x. The red function is the original function, and the blue one is its inverse. And you can see in each of these cases, they are mirror images, reflections of each other across the line y equals x. The rest of this video, though, is doing the challenging algebraic work to find them by taking the composition of two functions. If finding inverses or finding the composition of functions is a bit rusty, or you haven't learned it yet, make sure to check out my video links on both topics below. The first and most important video would be how to find the composition of functions. That's going to be the skill that I use specifically in the rest of this video. Since I'm strictly going over verifying that these two functions are inverses, you will need to know how to take compositions to do so. You may also want to check out my video on inverse functions. While this is not strictly necessary to solve these problems, you may want to know how the inverse functions are found. You might also have homework that asks you first to find the inverse and then verify it. In this case, you might need all three videos. Let's go ahead and get started. This is the first set of functions that I'm going to verify. Then we're going to move on to slightly more challenging functions. And finally, we're going to work with two rational functions that require a little bit more algebra to solve. If you want to skip to any of these functions directly, make sure to check out my chapter links below. Let's get started with our first two functions. So the question we're being asked is to verify if these two functions are inverses. We're not being asked to find the inverse, but we're being asked to pretend that the two functions are inverses to each other, and we want to algebraically prove that. We're going to use the composition of functions in order to do it. We are going to take f of g of x and find an answer. Then we're going to do the reverse. We're going to take g of f of x and find that answer. If those two answers match, then we know that these two functions are inverses to each other. Let's get started with the first one. Remember that to take the composition of two functions, we are taking g of x in this case and plugging it into f of x. In other words, it's nested inside, like this. So I'm going to copy down f of x. Everywhere that there is an x, I am going to plug g. So in this case, I have a single x right here. So I am going to plug in g. X minus 3 over 2. Don't forget about the plus 3 afterwards. This 2 needs to distribute into this parentheses. 2 and 2 cancel each other out. So I'm left with x minus 3 plus 3. Negative 3 and positive 3 cancel, so I'm left with x. This means that f of g of x equals x. Let's go ahead and verify that the other one is exactly the same. Remember that this means that f of x is nested inside of g of x. So we're going to copy down g of x first, and everywhere that you see an x, you're going to plug in f of x. F of x in this case is 2x plus 3, so I'm going to put it right here. The rest of the function stays the same. And now I'm going to simplify. There's not a whole lot of simplification that needs to be done here. Positive 3 and negative 3 cancel each other out, and that leaves me with 2x over 2. 2 over 2 also cancel each other out, so I'm left with x in this case as well. That means g of f of x is x. Since these two match, I have officially verified that they're inverses to each other. Let's try a slightly more challenging one. Once again, we are going to verify that f of g of x is equal to g of f of x. Let's start with f of g of x. Remember that this means that g of x is nested inside of f of x. So we're going to copy down f of x first. Everywhere that we see x, we're going to plug in g of x. That means we're rewriting the function here with g of x in parentheses. Since there's nothing in front of this parentheses, we can disregard it. If it's easier, we can even erase it. Positive 5 and negative 5 cancel each other out. So what I have left in this cubed parentheses is the cubed root of x. Remember that a cube and a cubed root cancel each other out. So what I'm left with is x. That means that f of g of x equals x. Let's verify that the second one is the same. Remember that this means that f of x is nested inside of g of x. That means we're going to start by copying down g of x first. Everywhere that I see an x, I am going to plug in f of x. So we're going to rewrite our equation here. And in parentheses, we're going to put f of x. Don't forget the plus 5 that's at the end of g of x. Now be very careful here. Inside of the cubed root is the parentheses cubed. The plus 5 is separate from the cubed root. Remember that a cube and a cubed root cancel each other out. So we're going to be left with x minus 5 plus 5. These also cancel each other out, and so we're left with x. We have verified that g of f of x is the same as f of g of x. Since they're the same, this means we've verified their inverses. All right, are you ready for the last challenging one? All right, I'm going to do myself a favor and just remind myself that this one is nested inside of f of x, and that this one is nested inside of g of x. I'm going to leave myself a little bit of extra room because there's quite a few steps here. First, I'm going to copy down f of x, but to save some room, I'm going to plug g of x right in. That means that everywhere that I have an x, I'm going to take g of x and plug it in. So I have a 3, and in parentheses, my g of x is x plus 4 over 3 minus 2x. On the top, this is minus 4 over 2, and I'm plugging in exactly the same thing on the bottom. And this is plus 1. My very first step needs to be distributing these whole numbers into that fraction. When I do that, it is only going to multiply the numerator. So 3 times x is 3x. 3 times 4 is 12. And the denominator is 3 minus 2x. And the whole thing is subtracting 4. Now I'm going to do myself a favor and go ahead and put that over 1. In the denominator, I have the same thing. 2 times x is 2x. 2 times 4 is 8. And the denominator is 3 minus 2x. This is adding 1, and again, I'm going to do myself a favor by turning it into a fraction. To find a common denominator in my numerator, I need to multiply both the top and bottom by this denominator. I don't need to worry about this denominator because I'm really technically multiplying this side times 1 over 1 and this side times 3 minus 2x over 3 minus 2x. On the bottom, I'm doing exactly the same thing, since they have exactly the same denominator. Now we have quite a long string of things with a common denominator in the numerator. So this is 3x plus 12 minus 4 times 3, so negative 12, minus 4 times negative 2x, so positive 8x. Let me slow down for a minute and show that to you. This subtraction is really making this 4 negative. So a negative 4 times a positive 3 is a negative 12. And a negative 4 times a negative 2x is a positive 8x. The denominator is now 3 minus 2x, just like it was before. This is my large fraction line, the one that's separating the numerator's fraction from the denominator's fraction. Now we're going to do exactly the same thing down here. We have 2x plus 8, and 1 times 3 is 3, and 1 times negative 2x is negative 2x, and we have 3 minus 2x in the denominator. Now luckily, we have quite a few things that can be canceled out or simplified. Positive 12 and negative 12 cancel each other out in this numerator. And so I can add 3x plus 8x into 11x. And the denominator is 3 minus 2x. In this denominator, 2x and negative 2x cancel each other out, and I can add together 8 plus 3. That makes 11. Also over 3 minus 2x. Now remember that when we have two fractions in the numerator and denominator, this line actually is a fraction. That means that we can bring it to the top by turning it into a multiplication problem and taking the reciprocal of this fraction. Reciprocal simply means to flip it upside down. This is really lucky, as we can cancel out anything that is exactly the same on the top and the bottom as long as it is separated by multiplication. That allows us to cancel out these two expressions and the number 11. leaving only this x. That means that I have verified that f of g of x equals x. Whew. And that's only half of the verification needed for this problem. Let's do the second half now. We definitely need a clean slate, or in your case, a second sheet of paper, or maybe the bottom half of your paper, in order to verify in the reverse. Remember that this is going to be that f of x is nested inside of g of x. So we're going to start by writing g of x down. But I'm going to go ahead and save myself a little bit of space by putting parentheses around the x's where I'm going to plug in f of x. Let me do that in the color that I'll actually be doing it in, though. So this first x is actually going to be represented by f of x as I'm plugging it in. The rest of this is the g function plus 4. On the bottom, I have 3 minus 2, and in parentheses again, all of f of x. You can already tell that once again, I have lots of fraction work to do. So in the numerator, I'm going to go ahead and save myself a little bit of time. I don't have anything distributing here, so I can simply get rid of these parentheses. I can then also turn this to a fraction and multiply the top and bottom by 2x plus 1 to find a common denominator. That means that over here, I have 3x minus 4 on top, plus 4 times 2x is 8x, and 4 times 1 is 4. The denominator then is 2x plus 1. On the bottom, I have 2 that needs to be distributed into this numerator. So I'm going to go ahead and do that over here. That first 3 can be turned into a fraction. Now I'm going to make this a plus because instead of thinking about it as minus 2, I'm going to think about it as plus negative 2 distributed in here. So the negative 2 times 3x makes negative 6x. Negative 2 times negative 4 is positive 8. In the bottom, I have the common denominator, 2x plus 1, which I'm going to use now to make it common with the fraction 3 over 1. I'm going to rewrite this one more time down here. I'm going to make this a little bit more simple, though. You can see that 3x and 8x will combine, but negative 4 and positive 4 cancel each other out. That means I'm left with 11x over 2x plus 1. In the denominator, I'm going to rewrite 3 times 2x plus 3 makes 6x plus 3 plus negative 6x, so I can write that now as minus 6x plus 8. And again, with the common denominator, 2x plus 1. One more time, we're going to go ahead and make this simple. Down here, we have a couple things that can cancel, the positive 6x and the negative 6x. The 3 plus the 8 make 11, all over 2x plus 1. Again, remember that if we have a fraction in the numerator and the denominator, we can consider this division, bring this up, and multiply by its reciprocal. This is really handy, as the 11s can cancel, and so can the 2x plus 1. This leaves just x right here. And now I have verified that g of f of x is x. Since I also previously verified that f of g of x is x, I have proven that these are inverses to each other. Let me go ahead and take a moment to write that here. They are the same, and so therefore, yes, we've proven it. Don't forget to like or subscribe below, and if you have any questions, leave them in the comments. Good luck!